Thank you. Okay, awesome. I'm not sure if I'm lucky or unlucky. Last talk for the day. I'm sure all of you all are full in your tummies and waiting to go home, right? Okay, I'll try my best not to bore you all, not to make you all fall asleep. So this is something that we wanted to put out as Lowe's. I will be talking about the company as well. We've seen such wonderful things happening in the community, right, last couple of days, and we thought we'll share some of our learnings as well across to the community. Like one of them from Zerodha mentioned, these are our learnings. I think these were right fit for our kind of workloads. It may not be for yours. Maybe you can experiment, but what we want to share is we want to share our successful journey, so that Kubernetes, as all of you all know, is a big jargon today, right? And running databases on Kubernetes has been spoken about, and a lot of companies are venturing into that space. So we thought this is be an ideal time to just give you all a brief overview of how things work in terms of Kubernetes. So here I am today. Okay, I'll introduce myself. I'm Rejo. I'm the Senior Engineering Manager for Enterprise Architecture in Lowe's. I started off in Lowe's. My Lowe's journey started off as a lead engineer in the year 2020. And that is when we started off our exploring. That's when Lowe's started off exploring how do we actually handle our DB landscape or modernize our DB landscape. Okay, so basically our team is basically the data platform team, where we provision Postgres and n number of databases for our engineers in Lowe's. Okay, we build enterprise platforms at scale. Just to give you an overview of Lowe's, I'm sure when I introduce myself or my team out here to a lot of them during the conference, the first question was, what does your company do? So I thought I'll give you a quick overview of what Lowe's is. So Lowe's is a home improvement retail company. It is one of the largest in the world, mainly operating in the United States. We have about 1,700 stores in the US, and we operate with a revenue margin. Our revenues are about 90 billion a year. Okay, we are headquartered in North Carolina, Moseville. Okay, before I get on to Kubernetes, I thought I'll share what is Lowe's vision and why did we look at the Kubernetes route. Okay, these are the 5 things when we started off in 2020, and I thought I'll just put this across to you. What were we doing in terms of the vision was, we had a lot of monoliths like a lot of other companies do today, right? You're sitting on traditional hardware or your traditional software as well, and you're in a constant phase of changing your software, your hardware, and with all the new things that are coming into technology, right? That is one of the things that we had in our vision, moving away from our monoliths and getting into microservices. Second, we were looking at public-private cloud evangelization. Basically, we already had something running in our public clouds, and we were in the verge of building our own private clouds. And how do we manage both in tandem? The others that we have today is omni-channel expansion, modernization of our pro platform, faster time to market. As you're in retail, you will have to ensure that all your departments, from supply chain to merchandising, all of them are in tandem, and you bring things faster to the market, right? And for a company like Lowe's, which is operating about 1,700 stores, you can imagine the amount of supply chain applications that are running behind to cater to this huge number of stores. So that was also in terms of faster time to market. Okay, I'll get into the point that we're talking today. What's in store for today? One, we talk about Lowe's modernization journey. I'll give you a brief stat of what is the DB landscape of Postgres in K8 looks like. Give you a high-level implementation overview. What were the implementation challenges? Maybe I'll deep dive on a couple of them because of the lack of time. And what are the open challenges that we have today in terms of running Postgres and Kubernetes? Like I said, modernization journey, right? We were in the path of moving our workloads from monoliths. We were breaking them down into microservices. And the first thing when you look at microservices is every microservice, on a majority, each microservice will have its own database, right? And while we were going that path, we had our current database setups on VMs. And as you know, like any other company, if at all you want to get your database on VMs, I know a lot of things are automated, but it used to happen over a backlog chaining. When I say backlog chaining, you basically place a Jira request, an application team places a Jira request, it goes into the VM provisioning team, the VM provisioning team again transfers that to the database team, you basically install things at the database level, and eventually it is given out to your application teams, right? So this was good, it was working for us then, but as we looked at our vision and as we were progressing, suddenly we had too many things that were happening in terms of our DB landscape, okay? Like you know, like I mentioned, if you have to support a $90 billion company, your platform has to be great, right? Your engineers should not wait for your databases. So basically, that was one of the challenges that we faced. One, manual provisioning in terms of scaling our current landscape and also our day two operations. These were the challenges that we had as we started growing, and we thought we should do something better about this. That is when we looked at Kubernetes. In terms of Kubernetes, if I have to talk, we were great at our applications, stateless applications. We were doing well, and with the growing landscape and challenges with our VM setups, we thought, why not look at Kubernetes? This happened in the year 2020, and a couple of years back, it was even still. People were hesitant to move into Kubernetes, but we took the challenge. We thought we will give it a try in terms of Kubernetes and see how things can work at Kubernetes. If you look at Kubernetes, the bigger elephant than Postgres, you have a lot of jargons, right, in terms of the different objects in Kubernetes, like you have persistent volume claims, storage class, endpoints, n number of things that we have listed here. This is something that you will have to know or understand while you work in Kubernetes, right? And we initially looked at having our own setup of building our own containers, trying to see if we can go through the complete chain of creating our own services, creating our own stateful set, building the endpoints, creating the service pieces. For the whole life cycle of what an operator does today, this is something that we did manually at first, but eventually we knew that this is going to be a tedious task, okay? And that is when we started exploring in terms of operators, and here we are today. So before I get into details of Kubernetes operator, how many of you all use Kubernetes here today? Awesome, that's a good number. And how many of you all have ventured into Kubernetes operators? Good, okay, nice. So for the others, I'll just give you a brief view of what Kubernetes operators is. So most of you all worked on Kubernetes, you know that anything that runs on Kubernetes, there is a control plane which controls anything that a pod. If I have to speak in terms of a pod, if I have to speak in terms of a service, if I have to speak in terms of an endpoint, all these is controlled via your control plane, and Your control plane is the one that you're basically the brain of your Kubernetes is one that handles what you have to do based on the specifications that you give, right? What do we look in terms of Kubernetes operators? Basically, you're building a custom controller outside of Kubernetes. Basically, you're using the functionality of Kubernetes and building your own manual controller, which controls anything in terms of a complex application like a database today. Like I said, we've been running most of our databases today, including Postgres on the operator model. And if I have to give you, if you look at the diagram here today, right? So you have the operator or the control loop that a custom controller, which is actually looking at what are the managed resources in terms of, if I have to talk about deployment, config map, service, these are the things that you are updating based on whatever complex application, whatever custom controller that you've built. Eventually, there is all these resources are being watched by your controller. Anything in terms of changes that you'll have to do goes back to your CRs, that is your custom resources. What are your specifications? What are your status? These are the things that you continue to monitor, and eventually the controller is the one which is taking care of the complete application. Like if you have to talk about Postgres itself today, right? If you have to do a HA today, if you are in a VM, you have your Petroni set up. So how does the whole switchover happen? Your backups, your upgrades, your anything to do with what you do as a DBA in terms of management is all controlled by your operator. Okay, so that is why we looked at operator, and we moved away from the initial phase where we were trying to build our own stateful sets, anything related to the individual components of Kubernetes, right? And that's how we looked at the operator model. Okay, so some things that we looked at in terms of operator journey. Before we went full-fledged on the operator piece, we started evaluating different operators in the industry. In terms of Postgres, we looked mainly on two different operators. One was Zalando and one was Crunchy. The two main operators that we saw around the year 2020, and I know EDB's ventured into the operator piece and it's open sourced. There are a lot of other operators also that have come in. But when we weighed our options with about 3 to 4 operators, we bottled down to Zalando and Crunchy. And when we evaluated further in terms of which operator we will take up, we eventually landed up with Zalando. Why Zalando? One, in terms of customizations that we saw, we could customize a lot of things. So Zalando did great when, in terms of the operator, when it came to the core of what Postgres does for you today. And anything over that, and you can easily extend it to whatever you wanted, and not basically take everything that Zalando has created in terms of the operator base. So for us, we had the feasibility to customize things in Zalando, be it our backups, be it our streaming, be it our DRs. All these pieces were done at our end. We just took the core pieces of Zalando, customized it to our needs. So that was in terms of evaluation. When it comes to operators or when it comes to databases, we are also talking about persistent volumes. So how do we handle that piece, right? Everybody has, the first question that comes to each of us is, how do we handle stateful sets? Yes, there is PVCs, there is storage classes today, but we also went a little more deep to see which are the different CSIs or storage solutions that we can use. So we went in for a lot of open source pieces like OpenEBS, we went for Rookchef, we did VMware vSAN, a lot of POCs on these storage providers or CSIs, I would say. And eventually the thing that fit us was VMware vSAN. One, because we were already using VMware, and second, when we looked at all the other ones, right, like RookSef, or we looked at OpenEBS, these were actually pulling in your storages from your local VMs, basically your VMs, which is again NAS mounted. And on that, they were having an extra abstraction layer of pulling the whole of that storage, and eventually starting off with eventually carving out those PVCs. What we did was we took, so since VMware was part of it, our infra already, we carved the PVCs directly from our vSAN storage, which allowed us to reduce that one level of abstraction, okay? And that's how we went further with the CSIPs. In terms of the other aspects like your CNI, and most of the things that we looked at in terms of the Kubernetes aspects also, I think we did a lot of POCs on Calico, a couple of other more in terms of our networking aspects as well. And eventually we took the one that fit our infra the best. So it took a lot in terms of planning and evaluation on what to look at. And even if we look at our current infra today, how do we do our provisioning, right? One, we'll have to look at how do we actually bring up, so this was basically in our private cloud, how do we provision our Kubernetes clusters, how do we deploy our Postgres operators, how do we eventually deploy or provision our DB clusters also, right? These are things that, we had to address. So we created a full-fledged self-service model, or in terms of DB provisioning, we also created a full-fledged K cluster provisioning as well. So today, if I have to provision a cluster, it just takes me a few minutes to deploy a complete cluster today. That is something that we could do even in case of a disaster. We were able to bring things up in a matter of few minutes. In terms of management, when we looked at, yes, there are a lot of things in Kubernetes today that you will have to look at. All of you all know the abstraction layers are many. So you will have to have some kind of management. So we talk about how did we do things in terms of Postgres at least. A lot of things that run in terms of a Kubernetes setup for us today, which has been in-house created to monitor our Kubernetes clusters. The last piece we talk about is expansion. Like I said, initially our DBs in VMs where we were not able to scale according to what we wanted. But with Kubernetes coming in, we thought it was a right fit because one, we could have multiple databases as containers running on VMs. We could add n number of nodes into our Kubernetes clusters. We could span our DB environment into multiple Kubernetes clusters as well. So that is one of the also add-ons that we got when we looked at expansion as well. Okay. I've spoken a lot about how did we plan. What are the benefits that we see with Postgres operator today? One, standardization. Standardization is something where it was a key for us. Like I mentioned, the number of databases that we provision are huge. It runs into thousands eventually. We have a huge landscape in terms of our VMs today. And if we have to move to the same thing into a better setup, our VMs, the standardization of VMs have, we still go back to VMs which are on different versions, different kind of setup. It's very difficult to manage when you're scaling into thousands, right? The operators gave us one flexibility where we could standardize the complete cluster, span it, like I said, as we span across different Kubernetes clusters, we were able to handle that piece as well. In terms of automation, the operator took care of a lot of things like backup, which we have in turn customized, but anything to do with HA, your basically provisioning the DB, all those pieces have been already taken care by the operator. So we were able to take additional advantages of that. In terms of scalability, we have massive nodes in our Kubernetes cluster to in turn use for application teams to have bigger clusters as well. Things that we have faced in terms of scalability is right sizing our Kubernetes cluster. At times we've got issues where we have provisioned our clusters in such a way, or provisioned our nodes in such a way that you're not completely utilizing things in the node capacity, right? So we had to multiple iterations on seeing what best fits your Kubernetes cluster in terms of right sizing your cluster and your nodes. That really helped in terms of our scaling. Ease of management, exactly like how the picture shows, right? Once you're in terms of management, it was getting really simple, and I would say it reduced about 70 to 80% of our database engineering work. We could focus more on code, and I think today we are one of the teams who write the maximum amount of code in the infra platform, be it Go, be it Python. We were able to bring most of the things as self-service, like what you get in any of the cloud providers today is being given to our engineers. Okay, just give you a quick high-level stats of how our landscape in operators look like. Initially, like I told you, manual provisioning. We moved away from provisioning a DB from days to minutes. I think fastest we've done is in 2 minutes, where somebody comes and provision a cluster and they get the details of the DB in 2 minutes. Like I earlier mentioned, manual intervention of DBA is reduced from to over 70 to 80%. Seamless upgrades, we were able to upgrade about hundreds of clusters in a matter of minutes. Our backups, our PITRs have all been automated. Just a click of a button and you will be able to retrieve your backups and do a PITR as well. Today, we run over 500 databases on the operator framework only. We know this is going to scale because it's just been a year since we've started provisioning at least Postgres on Kubernetes, and 500 is what we are today, but I'm sure this will go into thousands. We have a lot of databases that have been provisioned and decommissioned for POC related purposes. Since I told you we're moving into the microservices journey. Okay. We also have a good number of databases over a TB. I know it's difficult to handle things after a certain size, right? But we've seen that initially when we started off, I think we capped it at 300, we capped it at 500. Eventually, we're running about a good number of databases over 1 to 2 TB as well now, and we have not had any issues. Okay. I'll give you a quick high-level overview of how things are set up in the operator model. So basically, we have a self-service where any user or a developer comes in, places a request in terms of a form, and eventually that hits a Git API, goes into Helm, Argo. We have the Kubernetes setup where things are deployed. We have n number of monitoring pieces. I've just listed a few here on what we do. So this is how our high-level overview looks like. We use S3 massively for all our PITR, our backups, and also our DR is using S3 today. Just to get into a little more detail, how does our provisioning and deployment look like? Basically, like I mentioned, the developer places a DB request, it triggers a Git API. Eventually, you have the complete CRs templated in Git. Those templates are eventually formed, and your Argo basically deploys that complete Helm charts into Kubernetes. Yeah. Observability and alerting. This is something I just want to give a brief overview of how we do it. We've customized how things happen in terms of observability. We use Postgres exporter today, like a lot of you do. We have pod monitors getting things in terms of Prometheus, Grafana, Kibanas for your metrics and logging. We have Go Alert that we use in terms of alerting. So this is how the observability stacks look like. Implementation challenges. Some of the challenges that we saw while we were implementing. Sorry. Okay. So things when we look at implementation challenges, right? You know that your operator can do HA, but when you're running Kubernetes clusters, you're running it on a single data center, or at least we are running it on single data center. We don't have it. We don't have a multi-data center cluster setup. We had to look at how do we do HA along with while placing things into the same data center. How do we do our disaster recovery, replication across DCs, because we had to have something for a DR. How do we do ingress support was something that we looked at. Like all of you all know, your Nginx ingress supports HTTP and HTTPS, but when it had to go to TCP, how did we handle that? Basically, we had a load balancer created for that, and we have instead of routing it through one particular port, we had to break that down into multiple ports for each and every database. That was something that we set up. API server availability is something that most of the K8 clusters have an issue on, and since Kubernetes or since Postgres operators mainly rely on the API layer also, right? This becomes even more critical for us, because we were looking at Zalando, and Zalando basically looks at your Kubernetes etcd. We tried taking that off. We thought we'll run etcd out of the K8 API, but it didn't work. We had even more blunders created there, but eventually we landed using the K8 API itself. So we used the etcd of K8. What did we do in terms of API server availability? We used to have several crashes in terms of how we used to have several times where all of our DB clusters used to go into read-only modes because your API servers are not available. It is not able to access your etcd. Eventually, we looked at tuning our etcds. We brought in our control planes into such a way that we ran our control planes into our API server into one. We ran our API servers on different nodes. We broke our etcd into different nodes. We had to tune our transparent pages in such a way that it doesn't kill the containers that are running in these Linux systems, etc. Just for the matter of time, I'll just take two in detail. How did we do HA? So as all of you all know, or if you've already on Kubernetes, you will have multi-availability zones. This is something when you look at stateful sets, you will need to go into. Basically have in your same data center, you will have different availability zones. Today I've picturized two, but we have 3 availability zones today. And if you look at the diagram itself, it talks about when I'm running a Postgres cluster, how does my master and replica look like? It need not be on the it will not be on a same availability zone. We've ensured that is taken care of, and if any of the availability zones go down, it ensures that the other availability zone will be able to take up the load, and the switch, which the operator takes care of. Affinity rules that we've also brought in, so that one affinity rule so that it doesn't run on the same node. Second, your multi-availability zone so that it doesn't run on the same zone as well. Disaster recovery. Okay, this is something that we know how we did our HA. In terms of DR, we have 2 different data centers, or we have things running in cloud, we have things running in our data centers. How did we handle that? Like all of you all know, Kubernetes Operators 1, it is only cluster specific. You cannot span across until you have a multi-Kubernetes cluster. So basically what we did, we brought in LTM in front of each of our clusters. In front of the LTM, we had a GTM, so basically a global transport manager, and eventually these the GTM URLs are shared to our application teams. So in case of any issues with our primary cluster, they will not see any issues in terms of connectivity. It gets switched over to our standby clusters. And how do we do replication today? We use S3 buckets. So basically, our active cluster relays things into our S3, and S3 eventually replays everything back into standby cluster. We don't have this completely real time. It's a near real time feature. We accept that fact that this is the trade-off, but this is what has worked for us, and I think we've continued with this piece as well. A couple of open challenges that we see today. You saw the disaster recovery piece, where that is an automated fashion that we do today. But in terms of reverse failover post recovery, that is something that we're working on in terms of automation. Hasn't gone yet great so far, but we know that this will also be helpful as well. Storage level replication. If like I mentioned earlier, different CSI pieces that we worked on, VMware vSAN 1, it doesn't support storage level replication. Any other CSIs that we looked at, it does support, but when we eventually looked at bringing up our clusters in the other data centers, we've had several issues. We are still working on this aspects. I think our KA team is strong. I think we'll have something on this front as well. As we looked at all things that we did in terms of Kubernetes, we want to talk about trade-offs as well. It's very fancy, like I heard one of them talk about it yesterday. Yes, Kubernetes looks very fancy and everybody is using it in terms of stateless, but when you go into the stateful applications, it is complex. Glad that we have a great team in terms of Kubernetes who is ensuring that we keep up to our Kubernetes versions, anything in terms of upgrades, anything in terms of how to resolve critical issues. We have gone into massive issues where our clusters have crashed, but we have brought things back. That is what really matters, on how you get things back even if you crash, right? So complexity in handling Kubernetes clusters, that is something that we want to talk about. And secondly, additional overhead that you see because of the additional abstraction layers, because with multiple layers, your network hops are high, you might hit performance issues, or you might not get performance sometimes as expected. But that is the trade-offs that we knew that we will be facing. Like I said, it worked for us for whatever applications that we're running on our operator setup, and we accept these trade-offs as well. So it's been great so far. Yep, that's all that I had in terms of what we have done, in terms of our learnings. Yeah, I'm open for questions if any. Customizations, yes, the way we wanted. So some things that are already built in Zalando, like how your logical backups, all those pieces are great, but it didn't meet our infra needs. So we had to build in our own customizations on how we do our backups today and how we send things into our S3. So that is something that we worked upon. Other customizations, I would say a lot more into our how our self-service works. So we've been very self-service oriented. We want to see how things can be done in a click of a button, right? Be it anything that a DBA does today. You've seen in a lot of cloud services where you do a lot of things over a button, right? So that's how we've got a lot of customizations done in terms of Zalando as well. A lot of things that we have given back in terms of a community, also in terms of the other pieces like Go Alert, a lot more other products today. We are having a great team which is building out some exceptional things, and I'm sure we will be able to open source a lot of things that we are building here as well. So yeah, watch out for that as well. Yes. Yes. So basically, this is yeah. So what we do is while you have your DB setups provisioned by the developer, right? When the developer comes in, we're talking about what are the parameters that you want. But in terms of resources like CPU, memory, eventually you talk about what kind of workload are you running on. So those are the things that we are initially looking at, and provisioning the databases based on maybe a t-shirt sizing like you see in other instances today. But when it comes to anything to do with tuning parameters, that is where we still have to pitch in, right? You cannot have everything running on the same kind of flavored instances, right? So the DB team surely comes into that. We've been helping our application teams to go on par so that go on par in terms of how to tune these parameters as well. So we've got a brilliant team that does that piece as well, so that the interactions with the DBA also are minimal. So we are trying to educate our application teams to do those pieces also. But yes, surely those are the things that we are looking at in terms of a database engineering team as well.
Yeah, hey. I mean, I've actually run Postgres on Kubernetes before, and now I'm not. I'm happy about it. But I just wanted to ask, like, all these great things that you mentioned, you are running on Kubernetes and you have your operators.
Yes.
Do you foresee a place where people who are not using Kubernetes can still, like, get the benefits of an operator which doesn't need Kubernetes? Like, it's an operator where the administration knowledge is codified, but it can work with different platforms and not just Kubernetes, and like you can still do HA setup, backup, recovery, everything, and give a declarative configuration and just do it, and you don't need to run on a platform like Kubernetes.
Absolutely. So you're saying something out of Kubernetes, but on an operator framework, right? We've done this before in terms of VMs as well, maybe not in loads what I've done today. But on the similar lines, we've done something different where you're still running something like an operator, but outside of Kubernetes, your complete piece is automated on how you do all these things that I mentioned today. But when we looked at Kubernetes, operators was the right fit for us. So that's why we went ahead and
Cool.
Any other questions?
Who's your vendor for the S3? Because I assume you're in the data center using VMware and vSAN. What do you use for the S3?
I think we can speak that offline.
Any other questions?
Okay, sounds good. I'll be around. If at all you have anything in detail, please feel free to ping me. Okay, thank you.
Thank you so much. Yeah, that will be all for today for this room. Thank you. Bye-bye.